Hi class, we're going to look at our Chapter 1, Module 1, Lesson 1, Week 1, Database System Review Material, which is the PowerPoint slide from Cengage. So let's take a look. We're talking about database systems overall. We have some really outstanding objectives. We want to get clarification in our minds. What is the difference between data and information? What is a database? What kind of types are there? Why are they valuable for decision making? We want to talk about the importance of designing a database correctly so that it's usable. See how our modern databases have evolved from early file systems. We want to make sure that we have an understanding of flaws in basic file system data management. We're going to look at how database systems can overcome those flaws and look at the main functions of a database management system, or DBMS. In our today's world, we have data everywhere. It's ubiquitous, meaning it's abundant, global, just around us constantly, and it's very pervasive. We can't get away from it, and it persists with us. We know that our smart devices are tracking us and keeping track of even that kind of information. They're doing so by using databases, because databases give us the ability to make data persistent and shareable, but in a secure way. So databases are a little specialized. They give us the way to retrieve data very quickly. When we're looking at data, we're really just looking at raw facts, like information about a trip or information about the size of a room, just pieces of information. Whenever we're looking at that data, to gather information from it, we might need to process that raw data. We have to look at the context. We have to understand what's going on with that data for it to become a bedrock for us of knowledge. And of course, we need to make sure that our data is accurate so that the information we're gathering from it can be relevant, and we need it to be timely. A database gives us a unique structure that's just designed to hold and store data. When we're looking at being an end user, the kind of data that they're interested in could just be raw data. Maybe they are interested in, how much square footage an average home in Springfield, Missouri has, that kind of data. We would be looking at databases to gather that information. And how would we know what kind of information those databases contain? Well, that would be held within the metadata, because metadata is data about the data itself. So column names or relationships between different pieces of data. All of that information is the metadata. A database management system, again, acronym DBMS, is usually a collection of programs that can manage this database structure. Additionally, it usually controls access to the data stored in the database. When you think about a database, you might think of something like Google's huge stores of data about you. Whenever Google stores data, they have some level of control of that information, and they try to make sure that theoretically your data is not accessed by somebody who's not authorized. Now, this database management system is the intermediary, the middleman between the user and the database. So the database itself consists of binary data saved to hard drives, it's not necessarily meaningful unless it's processed by the database management system. The management system lets the user see an integrated view of the data and gives us more efficient and effective ways to manage our data. Database management systems give us sharing and security and data integration and access and decision-making capabilities and improved productivity. They're very important. Here's a great picture. This database management system illustrates how we have users and end users even on websites that are using our database management system to access all of the data that's available within our database file structure. We have metadata that describes that data, and then the actual data, our customers and our bills and information about the things that we sell. So we can see that the database management system plays a very important role in the company. We can have some different types of database management systems. One way of defining types is by the number of users. We could have a single user database system that only supports one user at a time. Those kinds of systems are actually very important and very widely used. We could have a multi-user database that supports multiple users at the same time. We can have work group databases. These support like a departmental number of users, 15 or 20 users, a specific group. Those are work group databases. And then enterprise databases are the huge databases that support many users across many departments of the large organizations that we see in the world today. We could also classify database management systems by where they run. We have some database management systems that are centralized. We only have the database at one location, and if anybody needs any information from the database, their query or their information has to be processed by that one central location. Conversely, we could have a distributed database where we have data distributed across several sites. Maybe our database exists in multiple locations, and each location only keeps track of the customers and products that are relevant to them. We can also have a cloud database, which is a database management system that's set up to run on a server that is based in the cloud, in the internet, maintained using cloud data services. This type of database can serve the needs of both centralized and distributed databases because it should be available in that one site, that one cloud location to all users no matter where they are. So it's kind of a different classification. Now, another way that we could classify database management systems is by what type of data they're used to save and process. A general purpose database could just be a wide variety of things. We could have a discipline specific database that contains data focused on specific subject areas. You may have used some discipline specific databases when you're searching for help for homework, when you find websites that have information saved about questions and problems. They're talking about that specific discipline. We also could be looking at a database that keeps track of, only screws or different parts that are used by a specific type of organization. An operational database is a database that's designed to support the day-to-day operations. So a factory might have an operational database that is constantly being updated with what parts are being produced, what location on the factory floor each part is at, all of that sort of information needed to operate our organization. Now, an analytical database stores historical data and business metrics. So we might use an analytical database for decision making. So a data warehouse stores data in a format optimized for decision support, like how many widgets did we sell this time last year? Do we have enough widgets to sell that many this year? Or do we need to make additional widgets? An online analytical processing, or OLAP database, gives us tools for retrieving, processing, and modeling data from the data warehouse. So our data warehouse comes with additional tools. These are used in business intelligence systems. These types of systems help us to capture and process business data to generate information to help management make decisions. We can also classify databases by the degree to which they structure the data that they contain. We can have unstructured data that is just in some sort of original raw state, or we could have structured data that results from some sort of formatting. Semi-structured data is data that's somewhere in between. One example is XML. An XML is a data representation that offers a textual format. As we look at databases, we're going to see that we have a lot of information on how to design a database. That's because databases can be very hard to change once they're set up. They can hold so much data that it can be very time consuming to restructure that data. We're going to focus on design so that our database structure will be flexible. We want to make sure that we know how we should format things to store and manage end user data. A well-designed database is going to facilitate the company and the organization for years to come. A poorly designed database is going to make things really difficult to follow, errors that could lead to poor decision making, and this can lead to a company's demise. In the early days of computer systems, we just had ways to try to represent old manual file systems. Way back before computers, they just had those, file folders, and everything was a piece of paper that they would put in a folder. And then early computerized systems allowed us to store some of that information and produce reports without having to go through so much paper. Now, as things have evolved, our modern end user productivity tools like Microsoft Excel and other tools give us a lot of flexibility and a lot of features that far exceed the capabilities of these early systems. The early systems, we only had things like data. When we think about data, we're thinking about an individual piece of data, like a phone number, a birth date, a customer name. None of this data has much meaning in and of itself. It has to be organized with other pieces of data to gain meaning. Each piece of data is contained in a field. A field is a group of characters that has a specific meaning, like the username field. That field is used to hold a particular user's username. A record is a piece of information that's contains logically related pieces of data. So if I am looking at a field of username and another field of birth date, if those two fields are in the same record, then they're related. They're working about describing the same user. When these individual records that describe each of my users have been put together, they can be contained within a file. So this is an old evolutionary file system type structure. Early file systems in computers allowed shared files, so we could keep track of those different fields and different records and share that information easier with other people in other departments. That was an important step because now everybody can see the sales information or the customer information. But when we're looking at file system data, like everybody's using the same Excel spreadsheet, it can offer some challenges. Working with Excel to develop these kinds of things can result in some lengthy development time. It can be hard and cumbersome to work through these old file systems, and usually we're missing system administration. If the user who created all of this leaves, it's often hard for others to know how to maintain the system. There's no real security. If somebody can access the files in a folder, they can access all of the files, and it could result in extensive programming. So what we'd like to do is make our programs independent of our data instead of having this structural dependence where every program has to know exactly what is contained in every record of every file. We can go to structural independence so that programs can ask for pieces of data without having to know what file and what record and what field those pieces of data are contained within. Now, data dependence, where we have to know where everything is, if we have a change to our data access, like we need to move from a hard drive to a optical drive or something like that, that can cause a lot of changes to all of our systems because we're very dependent on the structure of that data, its storage location, all of that sort of information. But if we can achieve this data independence, we can get away from being dependent on that underlying data structure. So this significance of data dependence is the difference between our logical and physical format. Say that again. Well, I want to be able to find customer data. I do not want to have to know that it's on the H drive in the folder named folder 123 and all of that storage information for the physical location of the data. Programmatically, I would like to just be able to say, I would like to logically see a customer's information. Now, another problem that old file systems give us is that we often are unnecessarily storing the same data at different places. We can have islands of information where we have all this great data, but we're not sharing it, and we can have different versions of the same data. You see some great examples in the reading material of spreadsheets that show data that is duplicated and how difficult it becomes to update that data correctly. Whenever we have this data that's duplicated or uncontrolled data redundancy, that in effect gives us poor data security. If we have people's social security numbers in multiple places, that in itself is not secure. We could have data inconsistency where in one place it says that Joe's social security number is this number, but in another place, the number is different. We are really susceptible to data entry errors. Those kinds of data inconsistencies can come from typos and data integrity problems, where we could have pieces of information, but other pieces of that information are missing. Whenever we have these data redundancies, we can have anomalies result. You know what an anomaly is? That's where something doesn't come out quite right. There is like a growth in it. It's something abnormal. Well, we can have these kind of anomalies result from duplicated data when the data needs to be updated. If Joe's name changes and Joe's name is in 15 different files, the chances are we are going to not get it updated correctly in all of those different places. That update anomaly can result in inconsistent data. We can have insertion anomalies where we add Mary Alice to our files, but she doesn't get added to the email exchange file, so she misses out on all sorts of messages. Insertion anomalies can happen like that when we have redundant data and the data does not get created in all of the different locations. Deletion anomalies then, as you can imagine, occur when we have data that is redundant and it's deleted, but yet it doesn't get properly deleted from all of the different locations where it's been saved. So anytime we're saving data redundantly, we're potentially causing trouble. We want to make sure that data is only stored in a single logical data repository. We want to have the ability to distribute that data among multiple facilities if we'd like. And our database management system gives us those kind of capabilities, and it eliminates most of the file system's inconsistencies, data anomalies, data dependence, and structural dependence problems. We can get away from all of that file system information. Now, our current database management software that's in use today stores the data structures, relationships between structures, and access paths so that we don't need to be concerned with that kind of information. The database management system takes care of it for us. So that database management system will do all of the defining and storing and managing of the data. Here's our database system where we can see that all of our users can ask for information from the DBMS. The DBMS will process the information and respond to queries. As compared to a file system setup where we might have the personnel department that can access one data island, the sales department accessing an additional island, and our accounting department with their own, where we have a hard time exchanging data and ideas. It makes it much more difficult for management to make decisions. Now, database management system has to have some resources to take care of all of these things for us. So we have several components that are involved in a database management system. Hardware, the computer resources; software, the database management system programs itself; the people that are involved in managing the system; the procedures that are developed; and of course the data that's stored within the database management system. This graphic displays all of the information and how these different people interact with the database management system. You can review that information and see that the database management system gives us one central point of contact to control all of our data's information. Some of the functions of a database management system include data dictionary management. The data dictionary stores the definition of all of the data elements, that metadata. The database management system will take care of data storage, making sure that we have enough space for all of the different pieces of information that need to be saved. The database management system will take care of data transformation and presentation, saving dates down to the millisecond, yet presenting them to us as year, month, day, if that's the formatting we desire. The database management system will take care of security management, multi-user access control, backup and recovery, and data integrity. Finally, our database management system will support data access languages, usually a query language, and our normal query language that's been in use is SQL, Structured Query Language. It is a de facto, which means in effect, a standard, and data access standard supported by the majority of database management system vendors. And you can see some database management systems that are no SQL or no SQL, and those are up and coming, and we do have some information available in our Cengage material about those if that's something that you're interested in. Now, our database has to allow communication, and so we accept end user requests for pieces of information from multiple different types of environments, programming environments, screen interfaces, and a lot of different ways we can interact with our database management system. Now, our database management system does have some disadvantages, though. They can cost more than just using straight file system information. It could be a little bit more complex to manage. We have to make sure that we keep it up to date. And if we decide to go with a certain database management system, we're dependent upon that system for the future. If we have a system that requires frequent upgrades and replacement cycles, we would definitely need to budget for that kind of updating. This list gives us an overview of several different job responsibility areas involved with the management of a database management system. So in summary, our data usually consists of raw facts, and these facts are usually stored in a database. The database design itself defines how the data is structured. We could structure according to the number of users, the location of the information, or data usage. And our databases evolved from manual and computerized file systems. So there were some limitations of file system data management, and DBMSs were developed to address those limitations and weaknesses. So sometimes when we run into something that's hard to understand or explain, it may be a result of that historical progress. Well, that's it for Module 1. Enjoy the reading material. I hope you'll get a lot out of it, and the try it and problem activities will help you deepen your understanding.